Welcome back, guys. Let us start with the static methods for list and collections. Look, in earlier session we have gone through the collection interface, then the list interface. We've also seen array list and linked list concrete classes. Alongside those interfaces and classes, we have seen the iterator interface, list iterator interface, comparator interface, and so on. Now we want to see the common static methods which are there defined in the collection interface for either list or all the collections. So collection interface, actually not a class, contains a few static methods, and those static methods are like sort, binary search, reverse, shuffle, and so on. Earlier in the previous unit, when you have covered array list class, you have seen those common static methods like search, binary search, shuffle, sort, and so on. So this is a list of all those static methods which will work on a list or a collection. So there is a sort method which will sort your list, given list. A sort method which will sort your list based on user defined comparator also. Then there is a binary search method which is going to search a list for particular key object, and searching can happen based on the comparator object user defined. Then there is a reverse method which is just going to return, or which is just going to reverse your entire list. There is a reverse order method which will return the comparator object that defines the reverse ordering. And this comparator object you can use in traverser also, or you can use in the compare method also, and so. Then there is a shuffle method which will randomly shuffle your list, or it will shuffle your list based on the random number given. Then there is a copy method which will create a destination list from the source list. There is n copies method which is going to create a list of n elements, and all those n elements will be the common object O. There is a fill method which is going to fill your entire list with a given object O. These are the methods which works on a list. Then there are few methods which simply works on all collections. So any of the collection you can use these methods, like min or max, defining a maximum or minimum value. And to define minimum or maximum, you can also give user defined comparator here also. Then there is a disjoint method which will simply check whether given two collections are disjoint or not. None of these two have a common object. Then there is a frequency method which will simply count the number of occurrences for this given object in a collection. So these are few common static methods which works on a list or a collection. List methods, you've already gone through these methods with the array list example in the previous unit. Let's have a look at few collection methods here. So I'm going back to the Eclipse. This is the same example we were working in the previous session, where we were already having array list and a linked list created. Right now we will be using this linked list. So focus here, a linked list having 5 objects in it already. So going back to the code, and let me uncomment this part which we want to see right now. So sorry, this is what we have already covered. Let me scroll down and have a static methods section. This is what we want to have a look at. So there is a sort method from collections. So collections.sort, we will sort our linked list. It is not sorted by default because the first city is Vadodara and then there are Bhuj, Rajkot and so on. So it is not sorted, but we are going to sort it. So after sorting, we will have a different linked list. We can reverse it. We can shuffle that linked list. If I shuffle it again, then I'll have a different output. We can find minimum and maximum from this linked list. So it is purely based on the string value. Okay. We can also find the frequency of given object in a linked list. So the frequency method. These are the collection methods. So let me save and run this code. This was the earlier linked list we were having, and after sorting we have this linked list which starts from Bhuj, then G, R, S and V is the ordered city list. If you reverse it, then you'll have the linked list starting from Vadodara going back to Bhuj. Okay, so that's the reverse order. Then we shuffle it. So this reversed linked list is going to be shuffled. So these elements will be simply shuffled randomly. We shuffle it again and we have the different output. Then from these cities, the minimum value is the Bhuj, maximum is the Vadodara. And if you simply look at the sorted manner, then the first one is the minimum, last one is the maximum value. And if you find out what is the frequency of Rajkot in a given linked list, then it occurs only once, so the frequency is 1. These are the few common methods of collections. You can also try out the list methods, where you can binary search, you can sort, you can shuffle, you can do whatever you want. Okay, it's not necessary that min and max works on linked list only. It also works on array list. It also works on stacks and queues that we will look later, because min and max are the collection methods, whereas sort and shuffle are the list methods. Okay, commenting this out again and going back to the presentation. Next thing we want to see is the vector and the stake classes. These two are concrete classes. Vector is a subclass of abstract list abstract class, and stack is a subclass of vector concrete class. Now vector is same as array list. The only difference here is vector contains the synchronized methods for accessing or modifying any elements in the vector. Synchronized methods will help you in preventing the data corruption when vector is accessed or modified through one or more threads concurrently. Now, if there is no need of multiple threads or the synchronization, then it is better to go for array list always. Okay, so let's have a look at vector. What are the methods in vector? So there is a no argument constructor which will generate a blank vector. Then there is a vector constructor with one parameter collection, a vector constructor with one parameter initial capacity, a vector constructor with two parameters, initial capacity and the capacity increment value. So whenever there is a need of incrementing this vector, this will be the incrementing size. Okay, then there is add element method, which will simply add the given element at the end. Then there is a capacity method, will simply return the current capacity of your vector. Copy into method, which will copy your vector into the given array. Then there is element at method, which will return the element at a given index. And there is elements method, which is just going to return the entire vector in the enumeration object. There is ensure capacity method, which is going to increment your vector with the increment capacity. Then there is first element method, will simply return the first element. Insert element at method, which is going to insert this element at a given index. Last element method, which will simply return the last element of your vector. Remove all elements, which is just going to make your vector empty. Remove element, so the given object element will be removed from the vector. Remove element at method, which is going to remove the element from the given index. Set element at method, which is going to set your element with this newly given object at a given index. Then set size is the method with which you can increase or decrease your vector size. And then there is trim to size method, which is just going to trim your vector to the required size. Now, these are the vector methods which you can use as per your need. Let's have a look at few vector methods in practical. So back to Eclipse here, and uncommenting the vector code. So we create a vector from the linked list. Earlier we are already having a linked list with 5 elements. All those 5 elements will become an element of our vector now, and we print that vector. So let's have a look at vector first, then we will go for different methods. Let me run this code, and we have a vector now. Now this vector is same as the linked list. So we have Vadodara, Bhuj, Gandhinagar, Rajkot and Surat cities here. Right now it is same. Now we are going to have few operations on this vector. Back to the code. Now I can remove an element, I can add an element, I can find the capacity, I can find the first element or last element, I can convert my entire vector to array, and so let's have a look at few of those methods. I can remove an element. A given element will be removed from my vector. Surat will be removed, and I can also remove an element from given position, so 0th index will also be removed. So actually I'm going to remove 2 elements here. The remaining size will be 3. Then I add 1 element at a given index. Look, add method is not actually the part of your vector class, but as vector is also extending or implementing the list interface, it has this method add at a particular index given object. Then add element will simply going to add your element at the end of your vector. So we remove 2 elements, we add another 2 elements, and we have our vector with size 5 again. So the capacity will be 5. The first element will be the whatever first element we have after removing this one. Last element will be this one, whatever you have added here. Okay, so that is the capacity first and last. And then you can also copy your vector to an array, provided this array must have enough size to have all those elements from the vector. So it will copy all the elements into this array. Now we can iterate this array to print all those elements. So let me save and run this code to have a look at the output. So earlier we were having this vector. From this vector we remove Surat and we remove the first element. So from this one we remove Surat and we remove first one. So the remaining part is Bhuj, Gandhinagar and Rajkot here. Okay. Then what we do is we enter Jamnagar at second index value. So 0, 1 and 2. At Rajkot it is going to insert Jamnagar. So Rajkot will be pushed back. So we have Jamnagar and Rajkot here. And at the end it is going to add Ahmedabad. So we have Ahmedabad here. Capacity is 5. The first element is Bhuj, last element is Ahmedabad here. And when you convert this entire vector to array, you can also iterate it. So we have all those elements one by one here. That's the vector. Okay. Back to presentations. Next is the stack. Stack you already know. Stack is the last in first out data structure, and it has few common operations like push, pop, pick and so on. So here in the Java, stack is a concrete class which extends the vector concrete class. Vector extends the abstract list abstract class. It also implements the list interface, and list interface as well as abstract list class both are going to implement the collection interface. So all those methods that we have seen earlier are going to be the part of stack class. But here what we do is we only going to use stack methods. Now stack has one constructor stack which will create an empty stack. You can check whether your stack is currently empty or not using empty method. Now there are three methods which are simply push a given element, pick the top element, will not remove it, pop the top element, which will remove the top element also and it will return it, and you can search a particular object in the stack. So these are the stack methods. As you all know, it works as last in first out. So whatever the element was pushed last, it is going to be popped first. So let's have a look at stack now. I'm going to comment this much part. So we have vector as it is, okay, and down here I am just going to have a look at the stack. So we create an empty stack and then we push two elements, Rajkot and Bhuj. The first one is Rajkot and second one is Bhuj. So Bhuj will be the top element. And then we simply print the stack. So let me save and run this code and have a look at the stack. So the first one is Rajkot, second one is Bhuj, but this is the top element. So refer your top to be at this position. Okay. And then let's have a look at few stack methods. So we can have a look at the size of a stack. We can have a look at what is the top element of the stack, and then we can search a particular element within a stack. So if it founds a Rajkot, it will return one, or sorry, it will return the position within a stack of that element. And if it do not found this element, then it returns -1. So anything that is greater than -1 will be the position of Rajkot. So it found. Then we can pop an element. Now we have added two elements. So we can pop two elements here, and then we can check whether stack is empty or not. So let me save and run this code. So we have two elements here, Rajkot and Bhuj. So size is 2. The top element is Bhuj, so when we pick, it is going to return Bhuj. If we want to search Rajkot, yes, it found it. And then we start popping the element. The first one to be popped will be the Bhuj here, and the second one will be the Rajkot. And when we pop both the elements, our stack becomes empty. Okay, now remember, if you still going to pop your another element, so at the time of popping an element, if your stack is empty, then it is going to throw an exception. So Bhuj is popped, Rajkot is popped, and now your stack is empty. Still you are going to pop it. So what it does is, it is going to throw an exception. Okay, the exception is empty stack exception. So whenever you are popping an element, make sure you are writing this code in try catch block, and then you throw the proper empty stack exception to the callee method. Let me comment this part. So that is the stack. Back to presentation. Next one is the queue and the priority queue. As you all know that queue is first in first out data structure. Priority queue is also first in first out, but based on the priority assigned to each and every element and so on. So let's have a look at queue. Now queue in a collection framework of Java is actually the interface. It is not a concrete class. And this queue interface implements the collection interface, so it has all those common methods. So let's have a look at what are the methods that are defined in the queue. So there is offer method, which works as inserting an element. So offer element. Then there is pick method, which is simply going to return the first element. It will not remove it. Poll method, which is going to remove the first element and return it. Remove method will also be returning the first element. It will also remove the first element. But the difference here in poll and remove is, if your queue is already empty, then poll method will return null, but remove method will throw an exception. Likewise here, pick is going to return the first element. Element is also going to return the first element, head of the queue. But the difference here is, pick method in case of empty queue will return null, whereas element method in terms of empty queue will throw an exception. So this is the queue interface. Let's have a look at the implementation part of a queue here. So I will entirely comment this stack part and have a look at queue here. Now look, queue is interface, so you can never instantiate any interface. This is not possible. So what we actually need to do is, we want to have a queue of string, but we always need to instantiate a concrete class. And if you remember that hierarchy that we have seen in the earlier session, then linked list is a concrete class which indirectly implements the queue. So we can use linked list here. So we will instantiate a linked list object, and we will store that object in a queue data type. so that we can use offer method, which will insert Gandhinagar at the first position. Again offer Surat, so it will insert Surat at the second position. And when we print that entire queue, we are going to have that queue on the console screen. So if I run this code, we will have a queue with Gandhinagar and Surat. Now this is the first position and this is the last position. So like stack, we can have the common methods here. We can have a size, we can look at the pick and element both. We can have a look at poll and remove both. So if I run this code, I'm going to have size equals to 2. If I pick and find the element from the first position, it is always going to give me the Gandhinagar. So pick is Gandhinagar, element is also Gandhinagar. Now if I poll, then it will return first element, it will also remove it. So the first one is Gandhinagar, it will return a Gandhinagar and it will remove it. And when I execute remove, it is going to give me the first element, which is Surat now. It is going to return a Surat and it will also remove it. So after removing all these elements, my queue is empty. If I execute these methods now, poll, remove, pick, or element, anything, so then poll and pick will return null, whereas remove an element, okay, that will throw an exception. So let's have a look at poll and remove first. Poll is going to return null. So poll is going to return null, but this remove method is going to throw an exception, right? Similarly, if I comment these two and check these pick an element, then pick is going to return null, pick is going to return null, but element is going to throw an exception. So these are the examples of queue methods. But remember, queue is an interface. You can never instantiate any interface. Always need to go for concrete class. So we use linked list here. That is queue. Back to presentation. Then we want to look at the priority queue class. Priority queue is a concrete class, so you can directly instantiate this class. By default, priority queue has a ordered list, ordered elements according to their natural ordering using the comparable. So if we create a string priority queue, then the strings are compared internally and the smaller string will be the first, larger string will be the last. So that's the default comparable ordering. The element with the list value will be the first one having highest priority, and it will be the first to be removed. Now several elements with the same priority is there, then in that case this tie will be broken arbitrarily. There is no rule, this will be the first or the second, and so. And you can also specify your own order by having the comparator object passed in the priority queue constructor. So let's have a look at priority queue class. It has a no argument constructor which will create empty priority queue. It has a constructor with one parameter initial capacity. It has a constructor with one parameter having entire collection, so all these elements will be the part of priority queue. It has a constructor with initial capacity and the comparator object, so you can give your comparator, user defined comparator object here. So these are the priority queue constructors. Now this priority queue class implements the queue interface, so it has all those common methods like offer, poll, remove, pick element, and so on. Let's have a look at priority queue here. I'll comment these things. So I will show the queue as it is, and then we want to see at the priority queue. So we can directly instantiate a priority queue. We have a PQ variable where I'm going to offer 3 elements right now: Rajkot, Bhuj, and Ahmedabad, and I print my priority queue. Let me run this code and have a look at the priority queue here. Look, the cities that we offer was, the first one was Rajkot, second one was Bhuj, and the third one was the Ahmedabad. But based on the default string comparator, Ahmedabad comes first because of its priority. Bhuj goes to last. Rajkot will be at the second. Now this is based on the length of the string actually. Ahmedabad has the highest length, then the second length value is the Rajkot, and the shortest one is the Bhuj. So based on the length, default comparator works on the length of a string, and this is how your priority queue prepared. Okay, now let's have a look at let's create a new priority queue here. Okay, let me save. So I create a priority queue with 3 size, and here I do the length comparator. I define the default length comparator here. So if you remember, we were having list comparator class. Similar like that way, I have the length comparator here, which will implement the comparator interface on a string. It is going to compare 2 strings based on length. Okay, and if first one is the lesser, then it is going to have -1, equal, then 0, else +1. So based on the length increasing order, I am going to have these elements in my priority queue. So if I run this code, then this is what the result is. The default priority queue was based on a length, and it is going to have the highest priority for the lengthier object. But what I have done is I have given my length comparator, and based on my length comparator, it takes shortest length to be having the highest priority. So Bhuj is the first one, Rajkot is the second one, and Ahmedabad is the last one. Okay, so that's how our priority queue works. And this is actually the end of your unit 10. Thank you for joining. Bye bye.